right, so I have my app running here. Let's go ahead and submit some feedback. This yellow, not feeling it. So let's say that I really don't like this yellow. It's really jarring. It really is. So let's say that I prefer for it to be blue. All right, yes, please. Change the app color to blue, and you'll see that the app has now shifted its theme color to blue. Hi, I'm Khanh, a DevRel engineer on the Flutter team at Google.
Hey, I'm Andrew, a product manager on the Firebase team at Google.
Have you heard about these AI agents? Maybe your boss said that you need to integrate one into your app. As an engineer, one of the first things that I looked up after learning about AI agents was, how do I build one? Google search seems to indicate that many of you are asking the same questions. So in this video, we're going to show you how to build a multimodal agentic app with Flutter and Vertex AI in Firebase. We want you to leave this video feeling like building agentic apps is just as straightforward as building any other app that you're used to. And hopefully you'll think of agentic features and experiences as another tool in your app development toolbox. Okay, so what's on the agenda, Andrew?
First, we'll chat about generative AI and agents, just to make sure we're all on the same page. Then, we'll do a run-through of Flutter and Firebase, the tools we're using today. And finally, we're going to jump into the code for the app that you just saw at the start of the video. We'll get to agents soon, but first, let's take a step back and look at one of the foundational building blocks for agents, generative AI. Gen AI allows you to create new and innovative content and experiences by prompting large language models. With prompting, you can turn a few words into an explanation or code, an image, or even a video. Gemini is Google's multimodal AI model. Gemini 2.0 and 2.5 are Google's latest LLMs. It improves on Gemini 1.5's overall quality, has function calling, and supports multimodal live, which lets users have low latency, bidirectional voice and video interactions with Gemini. We've already seen a lot of examples and code on how to generate content with language models. So let's shift our focus towards Gen AI agents. What is it? An agent is an application that attempts to achieve a goal by observing the world and acting upon it, using the tools that it has at its disposal. Here's how it looks in practice. An agent is made up of three key components: a language model for reasoning, like Gemini, tools that enable it to interact with the outside world, whether that's making an API call to retrieve data or to take some kind of action. Keep in mind, the phrase tool and function calling are often used interchangeably and represent the same concept. Finally, it also processes information, makes decisions, and continues to iterate until its goal is reached or a stopping point criteria is met. Now that we know what agents are, let's take a look at how to build them into your apps with Flutter and Firebase. If you're a Flutter developer, chances are you've already used a Firebase service in one of your apps. But if this is the first time building with Firebase, it's an all-in-one app development platform that spans the entire development lifecycle. You can use it to build and run modern AI-powered experiences. On the build side, you can integrate AI capabilities into your applications. On the run side, you can use AI-assistive tools to optimize your app's quality and experience. Vertex AI in Firebase, which we'll call the Vertex SDK, is a part of the broader Firebase family of services. It's an easy way to add Gen AI to mobile and web apps in production. Yep, it's in GA, so you can add it to your Flutter app and ship it right to the App Store. The Vertex SDK allows you to easily access Gemini models using native code and supports a variety of features, such as multimodal prompting, JSON output in schemas, function calling, bidirectional streaming, and image generation. It's natively integrated with AppCheck, remote config, and cloud storage, so you don't have to wire them up yourself. What makes it exceptionally special is its production-ready architecture. By providing a native integration with AppCheck, the Vertex SDK allows you to protect your applications from abuse by rejecting illegitimate requests and only allowing real users to trigger Vertex API calls. The Vertex SDK is available on pub.dev as the Firebase Vertex AI package, so you can quickly add it to your Flutter projects by running a single command: Flutter pub add Firebase Vertex AI. If you can build a Flutter app, you can use the Vertex SDK. It's just another API call. So, why Flutter though?
Andrew, we're on the Flutter YouTube channel. I think everyone already knows why. But in case you're new to the channel, first, welcome. We're happy to have you here. And second, Flutter is the world's most popular multi-platform app development SDK. It enables you to build production-grade apps and deploy to iOS, Android, web, Windows, macOS, and Linux, all from a single code base. This means you can minimize development time and ship high-quality apps faster. Not to mention, using Flutter and the Vertex SDK together means that you don't have to switch between languages or frameworks. You don't even have to switch between projects or code bases. All of your code and prompts live within your Flutter project, written in Dart. Like Andrew said, if you can build a Flutter app, you can use the Vertex SDK, and vice versa. They're better together, sort of like macaroni and cheese.
Okay, now that we have all the context, let's jump into building the app. If you've used Flutter and Firebase together before, the setup process will look very familiar. You'll first want to make sure that your dev environment is set up with Flutter and the Flutterfire CLI tool. Then, head on over to the Firebase console at firebase.google.com and create a project. If you already have a project, you're already one step ahead. Then, jump over to the Vertex AI product page, configure your billing account, and enable the Vertex APIs. That's as much as you'll have to do in the Firebase console. Let's look at setting up your Flutter project. If you already have a Flutter project you'd like to work with, that's perfect. You can use it. If you're starting fresh, you can create a new project using the Flutter create command. Next, add the Firebase core and Firebase Vertex AI packages from pub.dev. Finally, you'll want to connect the Flutter app to the Firebase project using the Flutterfire configure command. In your Flutter code, you'll want to import the Firebase packages and initialize the Firebase app. Now, if you're already using Firebase in your app, you probably already have that initialize app code. It's the same across all of the Firebase packages. That's it for the project setup. Now you can make calls to Gemini using the Vertex SDK from within your Flutter app.
Let me tell you a story about how I came up with the concept for this demo app. I previously worked as a support engineer. Whether you're the user filing a complaint or the engineer supporting users, you know how the process goes. The user tries to do something, but it doesn't work the way that they want it to, so they open a ticket. An engineer reviews it and points to some docs, or they ask for some additional information. The user responds with the results or answers, and then the back and forth goes on for a few more cycles. Finally, the ticket is eventually closed. This process takes a lot of time from both the user and engineer. What if the engineer misses something in the user configuration, or perhaps a user overlooks a step in the instructions? What if we could insert an agent in the middle of this process to help both the user and the engineer? An agent that processes user feedback and takes action to make changes in the app on behalf of the user, collects all the necessary troubleshooting information like device info, battery info, settings, and change history, and helps to prioritize and categorize the feedback among all of the other tickets. Wouldn't an agent like this help to minimize the amount of back and forth that needs to happen between the user and the engineer? And that's how the Agentic App Manager prototype was born. Let's try this font here. I don't like this Georgia font. I want a more fun font. So we'll wait for that. And then you'll see it prompts you for a different font. In this case, it's Caveat, which is indeed a more fun font, most certainly. But now that font is too small. So we'll say this font size is way too small. It needs to be about 30%. Bigger. Yes, please. And as you can see, it makes the font much bigger and it's much more readable now. Now finally, let's pretend this page is scrolling really slowly, and go ahead and submit. And would you like to file a feedback report? Yes, please. And so there you go. And now you have the full feedback report with the user feedback, as well as the device and battery information there. And then there's a screenshot as well. So what did we just see? The app lets you file feedback by taking a screenshot, letting you annotate it, and then write some text. Then the agent does some reasoning, drawing conclusions as to why you might be filing that particular feedback. Say you don't like the color scheme and prefer blue. The agent determines that it has a tool to change that and does it for you. But of course, UX matters. You wouldn't want the UI to suddenly change out from under you, right? So the agent first uses another tool to show an alert modal, asking for confirmation before actually changing the color. And finally, if there are no tools that the agent can use or the setting change request is denied, the app automatically builds a standardized feedback report that helps the developer to prioritize and troubleshoot by collecting and summarizing all the available device and battery information, providing an action history, and generating tags along with a suggested priority level. You can see how the potential use case for an agent like this goes on and on. Take a moment to think about it. What are some of the other tools that you can give to an agent to make it even more useful? Here's the architecture for this agentic app manager. The Flutter app provides user feedback in the form of natural language text and a marked up screenshot. The Vertex SDK sends that input along with the system instructions that we've defined to the Gemini 2.0 model. The model then responds with function calls in order to fulfill its role of being a friendly and helpful app concierge. You can see how this levels up our use of generative AI. Not only is Gemini generating new content, but it's actually taking actions and making changes in order to fulfill its goal of being helpful to the user. Looking at this architecture diagram, it looks like any other app making API calls, right? There's some data being passed back and forth, functions being called. The real difference comes from, one, Gemini's ability to reason, understand, and process unstructured multimodal input, and two, its ability to determine an output based on the prompting. To build this type of agentic functionality, you first have to construct a Firebase Vertex AI generative model. For this particular prototype, we'll configure the generative model with Gemini 2.0 Flash. Then we give Gemini a list of tools or function calls that it can use. These tools can do things like modify parts of the app, retrieve device information, and file a feedback report. And finally, we define a system instruction to give the agent a persona and goal. More specifically, defining its goal of being a friendly and helpful app concierge, along with some additional instructions that we want it to follow. Once that's all configured, we can start a chat session. The nice thing about these chat sessions is that they store the chat history from our Gemini interactions. Otherwise, we'd have to implement our own chat history. From there, whenever the user hits submit feedback, our callback sends a message to Gemini with a prompt along with the feedback text and screenshot. When a response comes back, we check whether Gemini has made any function calls. Let's say Gemini has issued some tool calls, otherwise known as function calls. Keep in mind, Gemini doesn't actually execute the function itself. It essentially gives instructions that say, do this thing, but your app is ultimately responsible for actually doing the thing. Gemini is sort of like a backseat driver.
That's actually helpful.
Thanks for helping me land that point, Andrew. So with every response, we check the function call's name and then call the function that's responsible for doing the thing. Let's take a closer look at two of the tools that the Agentic App Manager has at its disposal. Each tool is defined as a function declaration. It's a declarative way of describing what a tool does. Each tool has a name and a description, along with a map of parameters and their descriptions. Remember that good tool descriptions are important because the LLM uses them to determine what the tool does. Meanwhile, good parameter descriptions will help it to generate more useful argument values with each function call. Here's the function declaration for the app color tool. This particular tool requires 3 integers, each representing the red, green, and blue channels in the RGB value. And here's the function that actually sets the app color. We grab the RGB parameter values that Gemini has generated from the function call object and update the app's color state. And here's the function declaration for the tool, which asks for user confirmation. You can see the parameter is a string that represents the question to ask the user, and for simplicity, the answer to this question needs to be either yes or no. So when the Gemini response invokes the ask confirmation tool, we pull the question that Gemini provided as a parameter from the function call object, drop it into the function that invokes the alert modal, take the response, which is true or false in place of yes or no, and send it back to Gemini as a chat message. Assuming the user responded yes, Gemini should then respond with another function call to execute the change. And that's how you build an agentic app with Vertex AI in Firebase and Flutter, implementing precisely this architecture diagram that we saw earlier. The app sends text and a screenshot to the Gemini model that's been configured with our system prompt. Then Gemini responds by calling various tools to make changes and take action in order to fulfill its goal. A quick aside here, before we jump to the next segment, I didn't actually build any of the feedback UI that you saw in the demo. The annotation canvas, the text field to type the feedback, it's all built into the feedback package from pub.dev. I built this fake email app, wrapped it in the feedback widget, and it just worked. Pretty awesome if you ask me. Definitely check it out if you haven't already. Now, as we were working on this demo, I felt like my fake mail app was a little bland. So let me show you something cool. I added profile pictures for the email senders.
What's so exciting about that? Isn't that how mail apps usually work?
Great question, Andrew. It's exciting because I actually used Imagen 3. It's an image generation model that's available through Vertex AI. The even more exciting part is that Imagen 3 is available through the Vertex SDK as well. So just like how we could access the Gemini 2.0 model through the Vertex SDK, you can do the same with Imagen 3. The Imagen Model API looks really similar to the Generative Model API, but notice that it's an Imagen Model constructor. Just like before, you specify a model and an image generation config. Here you can specify the number of images that you want back for each prompt. At the time of this recording, it'll default to 1 image, but you can get as many as 4 images if you wanted. Then you can call the generate images method with your prompt. Once the response comes back with the images, you can grab the image bytes and display them in your app using a memory image widget. Okay, but I do have one more thing to show you today. I was talking to one of our awesome Firebase engineers, and they mentioned a really cool feature that they were working on: bidirectional audio streaming using Gemini's Live API. In short, what if I could literally talk and have a conversation with Gemini in real time? I'd like to talk to the manager, please. Hey, Gemini.
Hello there. How can I help you today?
I don't like the purple color of this app. Can you change it to a blue, please?
Sure, I can help you with that. I can change the app color to blue. Would you like me to do that?
Yes, please. Cool, thanks. Can you also
You're
make
welcome.
the font a serif font, please?
Sure, I can change the font to a serif font. Would you like me to use Georgia, which is a highly readable serif typeface designed for screen use?
Yes. Never mind, I don't like that. Can we go back to the interfont, please? Okay, thanks. That's all I need.
You're
Bye,
welcome.
Gemini.
Goodbye. Have a great day.
Oh, that's what you meant. That's pretty cool. This is a great time for me to tell you that real-time bidirectional streaming is now available in preview, so you can try it out today in your Flutter apps.
And guess what? The code follows the same API structure as the generative models we've already used. You swap out your generative model constructor with a live generative model constructor. Specify a model that has Gemini Live API support, like Gemini 2.0 or Gemini 2.5. Provide a live generation config, which specifies the voice and response modality, which in this case is audio. And then you can reuse the same list of tools and system instructions. From there, you can start streaming your audio. Of course, once you're done building your agentic Flutter app, you have quite a few deployment options to pick from. Believe it or not, we managed to use 3 different generative models from the Vertex SDK. We first built our agentic app manager using a regular generative model with Gemini 2.0. Then we used the Imagen model to generate images with Imagen 3. And finally, we added real-time audio streaming with the new live generative model, also using Gemini 2.0. So Andrew, what are the high-level takeaways that everyone should take away from this video?
Well, there's a few things. Number one, language models like Gemini enable us as developers to craft better user experiences by understanding unstructured input paired with an ability to reason. Number two, Vertex AI in Firebase is an easy way for you to add Gen AI and agentic functionality into your Flutter apps in production. And number three, Flutter helps you ship your production-grade multi-platform apps faster with just one codebase.
And finally, we hope that we've been able to keep our promise, showing you that building agentic apps is as straightforward as building any other app that you're already experts at building. Hopefully, you now think of agentic features and experiences as another tool in your app development toolbox. It is software, just with a non-deterministic runtime. It's a new paradigm that we're all getting used to.
If you want access to the code for the app, head on over to the Flutter Demos repo at github.com/flutter/demos.
Thanks for taking the time out of your day to watch this video. Please drop us a comment if you have any questions or feedback. If you're working on a cool project with Flutter and Firebase, let us know as well. We'd love to see them. With that said, I think that's a wrap for us. Catch you next time. Bye.
Bye.